Welcome back to our Algebra 2 series. Today we are up to section 1.4 where we will be dividing radical expressions. Previously we saw that if you had a product, here a times b, as a radicand, you could split it into two separate radical expressions. And the inverse was true. If you were multiplying two radical expressions, you could combine the radicands into one single radical expression. Well, what about division? What if we're trying to take the square root of a fraction? Here we have a over b. Turns out the same kinds of rules apply for division. You can split it into two separate radical expressions. So we end up with the square root of a over the square root of b. The inverse is also true. So if you have two radical expressions as a fraction, you can combine them into a single radical expression, going the other way. So let's take a look at this example. We're trying to find the square root of 18 over 50. We know we can split this into two separate radical expressions. So we end up with the square root of 18 over the square root of 50. From our previous sections, we know we can take that square root of 18 and split it into two separate products. Here we have the square root of 2 times the square root of 9, because 2 times 9 is 18. And we can do the same with the 50. Square root of 50 can turn into the square root of 2 times the square root of 25. These two root 2's will cancel themselves out, and we're left with just root 9 over root 25, both of which are convenient perfect squares, so we end up with 3 over 5. So let's look at it going the other way. Here we have a fraction with a radical expression on the top and the bottom. We know that we can combine it into one radical expression. So the fraction, 27 over 3, becomes the radicand. In this case, this simplifies pretty quickly. 27 divided by 3 is 9, so we're left with just the square root of 9, which is just 3. Finally, let's take a look at this example. Root 2 over root 3. There's not a whole lot we can do here. There's no perfect squares. There's no further simplification that can be done here. But we're not quite done yet. An expression containing radicals is simplified only when 1. The radicand contains no perfect squares. Okay, we're good here. 2. The expressions contain no fractional radicands. What that means is, say, the square root of a fraction. Here, we're only taking the square root of whole integers, so we're okay for this step too. And finally, the denominator contains no radicals. Uh-oh, we're violating rule number 3 here. We need to rationalize the denominator. We need to make the denominator of this fraction to be a not radical. So how do we go about doing that? This root 3 is the root of our problem, but it is also part of our solution. We can multiply by root 3 over root 3. Remember, this is the same thing as 1, so we're allowed to do this. So we can multiply across. We end up with root 2 times root 3 over root 3 times root 3. This becomes root 6 over root 9. And 9 is a nice, happy, perfect square. So our final answer is root 6 over 3. Let's jump over the whiteboard and do some examples. Okay, we're going to start with the square root of 9 over 49. Wait, hang on. I don't remember ordering anything. What is this? I knew this ruler would come in handy eventually. Let's get this open. What do we have here? Oh yeah, it's a cup of coffee I ordered. Cool. Alright. So we know we can take this fraction and split it into two radical expressions. So now we're left with some happy perfect squares here. So root 9, that's 3, and root 49 is 7, and that's it. Okay, let's try going the other way. We're going to take the square root of 75 over the square root of 15. Now, since we have a fraction with two radical expressions, we can treat it as one radical expression like this, 75 over 15. We're out to, swap like this going back and forth. So we can solve this part inside first. 75 divided by 15, well, it's just 5. So we end up with just root 5, and that's the answer. Okay, here's a slightly interesting problem. I'm going to take the square root of 3/4. So we're violating a rule here. We're trying to simplify this. We're taking the square root of a fraction. So this isn't allowed. So what I'm going to do is just break it up like we did up here. This equals root 3 over root 4. So now we're got in a case where we have a perfect square in the denominator as part of this, radical. So we can put root 3 over 2. So now we've rationalized the denominator, and we're in our simplest terms now. All right, let's clean this off and do some more examples. Okay, we're going to have another big square root here. Is that on the screen? That is just on the screen. Perfect. Of 2y over 5x cubed. Okay, so we have a fraction inside a radical. So we have to make Squidward happy and solve this, get rid of this. So we're going to first split this into 2y over root 5x cubed. Okay, so we got rid of the fraction, but now we have a radical in the denominator. So Squidward is still mad. So we need to rationalize the denominator by multiplying this whole thing by 1. And that 1 is going to be this entity over itself. So we're going to take this. Oh, run off the screen. Let's bring that back down. 5x cubed over root 5x cubed. So we're going to jot down here, because I know I'm going to run out of space. This turns into, so now we're multiplying across. We're just take all of these items and all these items. So 2 times y times 5 times x cubed. We end up with a 10 x cubed y all over 25x to the 6th. I'm gonna spell it out here. 25x to the 6th. See, when you do this, you're taking something, multiplying it by itself, and then finding the square root. So you end up getting rid of the square root sign because you're making a perfect square. So we kind of did that here. 25x to the 6th. So let's find the square root of that. We know it's going to be 5x cubed. And up here, we've got a 10, an x cubed, and a y. The only thing we can pull out is the x squared that's buried in this x cubed. So we'll leave an x behind, but an x is going to pop out. So we're going to have x times 10x squared y. See how? Oh, that's not x squared. That's just plain old x. So we have an x here and an x cubed down here. So one of those x's will cancel out, and that will equal the square root of 10xy all over 5x squared. And that's it for today. We'll see you next time.